Hi guys, in this video I'm going to demonstrate the solution for the pizzeria exercise you did last time. I know it's a very long case study, but then you just have to read it line by line and bedah siasat every single information given. And so let's say you have a pizza restaurant and you are making money of $110 per year. Sebab restoran you ada banyak untung, you decided to open up a new branch. Currently, the overhead cost is $50 per year. Overhead cost is the amount you need to pay for operational activities such as sewa kedai, bil elektrik, bil air, gaji pekerja and so on. In other words, it is the amount that goes out from your pocket lah. As you want to open up a new branch, you have two options or two alternatives. Either to set up a new shop at a faraway location, or you can just make do with a smaller shop at a nearby town. You wanted to know which is the best alternatives. So, we are going to bedah siasat the situation using the decision tree analysis. So, this is your current pizza shop. Sorry, it's ugly. I'm very bad at drawing. The profit is $110 and the overhead cost is $50. As there are two alternatives, let's make two branches. The first branch is the first alternative, which is to set up a new shop somewhere far, and the second branch is for the second alternative, which is to set up smaller shop at nearer location. Now I'm going to drag the second paragraph here so that it's easier for us to refer to. Okay, this paragraph describes the situation on the first alternative, which is if you set up a new shop. You are presented with three possible situations, which is if the economy is good, or if the economy remains the same, or if economy does bad. So there are three possible situations that will likely happen if you set up a new shop. Okay, each alternatives are represented with percentage of the probability that each situation happen. So we can see there is higher chance or higher percentage that the economy will do well. But then we also have to look into the situation if the economy remains the same or if the economy does bad. Back to our decision tree, we are going to break the first alternative into three smaller branches. The first branch represents the situation if economy is good with 37% chance. The second branch is the 29% likelihood that the economy remains the same. The third branch is the 34% likelihood that economy is bad. Okay, just make a quick check here. Remember the important point when deciding for the percentage of probabilities? The total percentage of all the branch should be equal to 100%. So let's check if it's true. 37% from the first alternative plus 29% from the second alternative and 34% from the third alternative. We got 100%. Okay, great. It's okay then. Now, let's bedah siasat the remaining sentences in the paragraph. Stated here is, if the economy is good, then there are 71% chance that you'll earn $400 of profit. Let's make a branch for this. This is a possible situation if the economy is good. The second situation is there are 29% chance that you earn profit of $207 in a good economic condition. Let's make the branch for this part. Okay, done. Let's move on. Stated here that if economy stays the same, then you'll earn $85 of profit. So this is the payoff or the impact for the second situation. Finally, it is stated here that if economy is bad, you'll just earn $25 of profit. Let's do the branch for this part. Seems like you are still making money in a bad economy situation, but at a much lower amount lah compared to the other economic situation. I'm going to move this back and we'll bring the third paragraph to this side. The third paragraph explains the situation if you are to open up a small shop at nearby town. There are equal probabilities that the economy do well or economy stays the same and economy is bad. Okay, so we can break this into three smaller branches. The first branch is if the economy is good, the second branch if the economy remains the same, and the third branch if the economy does bad. Now, what are the amount of probabilities for each situation? The key word here is equal probabilities. we know that the total for all probabilities must be 100%. So if each branch have equal probabilities, then we just divide 100% into 3 branches and we will get 33.3333333% for each alternative. There are more information in this paragraph. Stated here is, if the economy is good, then the profit would be 70% higher than the profit that you earn from your current shop. Oh, that's great. Untung banyak besar dekat sini. If current profit is $110, so 70% higher means 70% of current profit plus your current profit of $110. Sebab higher kan? So you will get $187 in this situation. Also mentioned here is, if economy stays the same, 62% chance profit increase to $166 and 38 chances profit increase to $156. So you see, there are more alternatives here. So let's make up smaller branch for this situation. The first branch has 62% of $166 profit and second branch is 38% likeliness of $156 profit. Finally, if the economy is bad, stated here is that your profit is only 50% from the current profit. Hilang duit dekat sini, whereby you only earn separuh je daripada untung kedai yang asal. So 50% of current profit of $110 is equals to $55. Finally, the last paragraph. Where should we put it? Okay, anyway, I think we have completed our decision tree. Let's just highlight the probabilities percentage with this green highlighter and the impact of payoff amount with this striking blue highlighter. Okay, so let's move this third paragraph here. It says here that if you open up a new shop, then the cost would be $30. Ini duit yang keluar ya kalau buka kedai baru, and we'll make it red color just to indicate duit keluar. It also mentions that the overhead cost of nearest city, which is a smaller shop, is 40% of the current overhead, which is $50. So we'll get $20 overhead cost if we set up a smaller shop. Again, we'll make it red color to indicate duit keluar. Nice. Now let's just remove all this text and focus on our decision tree. As you can see, there are multiple branches in our decision tree. How do we solve this kind of problem? Oh man, looks tricky. But not really. The more convenient way is to solve for the smaller branches first. Make sure each branch have the probability and impact pairing. Let us solve the quantitative analysis for the first situation, which is to set up a new shop. To make it easier for you to refer, let me just label each branch of multiple alternatives with labels as in A, B, C, D, E, F, and the smaller branch with G, H, and I, and J. Okay, as I mentioned earlier, we are going to solve for the smaller branch first, which is branch G and H. We are going to find the equivalent value for both branch G and H. From branch G, multiply 71% of probability with $400 payoff and total with branch H, by which you multiply 29% probability with $207 of payoff. Use your calculator and you'll get $344.03. Wow, that's huge. Okay, is there any smaller branches left? Nope, only the ABC branch are left. So we can find the equivalent value for branch A, B, and C. The equivalent value we calculated just now has become the monetary value for branch GH. We will highlight this with striking blue color. Now we have a matching pair of probability and impact. So we can solve for branch A, B, and C. From branch A, 37% probability or 0.37 multiply with the payoff amount, which is the $344 we calculated just now, plus with branch B, which is 29% probability or 0.29 multiply with the impact of $85 and plus with branch C, which is 34% probability or 0.34 multiply with $25 payoff. Use your calculator and we will get $160.44. Is this the final value of opening up a new shop? No, do not forget that if you open new shop, there are an incurred cost of $30. Remember, this red color font, money going out. So you have to deduct the total amount with $30. Finally, the equivalent value if you open up a new shop is $130.44. I think you already get the idea by now. So you can solve for the smaller shop alternative on your own, and the final equivalent value is $114.73. Let's compare the equivalent value for both scenarios and choose the higher one. 130 is definitely larger than $114, so we can say that opening up a new shop at faraway location is the better alternative. Please do not forget to include the concluding statement. Therefore, the better option is to open up a new shop at a faraway town because equivalent value is higher. Ta-da! This problem is solved.